And now it's time for our guest joining us, Will Kalif, writer of See with a Small Telescope, 101 Cosmic Wonders, including planets, moons, comets, galaxies, nebulae, star clusters, and more. Will, welcome to the Weekly Space Hangout.
Thank you very much, Fraser. Thanks for having me. It's great to be here.
Right on. So how long ago did your book come out?
Just the end of December, so about 2 months.
Awesome. And so just give people some background about yourself.
Sure, I'm a writer, and I've been an amateur astronomer for going on maybe 40 years now. So it was kind of nice to pair the two together and write a book about astronomy and using a telescope.
And actually, before we started the show, you pointed behind you to a handmade Dobsonian there.
Oh yeah, that's
there. It is
right there. It's an 8-inch Dob, short focal, a fast telescope, and I have a kind of like a specialized mount I made there rather than the normal Dob. It's actually a cabinet. You can open it, and I keep my eyepieces and stuff in there. It's kind of nice.
So yeah. You've got it now. It's sort of shorter than a regular 8-inch Dob that I've seen.
Sure, it has a really short focal length. Yeah, so it's a little bit different.
So it's
easier to handle.
It's a little faster.
Yeah, it's faster.
Yeah. Great. So we'll get a bit into your background a bit, but let's talk about the book first. What's it all about?
It's all about let me see. An affliction. It's all about dispelling an affliction called TCD syndrome.
TCD.
Sure, you won't find it in the book.
Total.
No.
I don't know what the.
No, I'll give you a hint. I over the course of years, I guess decades now of using small telescopes and helping other people, I find this unusual kind of pattern where a person might get a telescope for Christmas or birthday or get themselves one, use it a time or two, get lost, and before you know it, the telescope ends up either in the basement or the attic or the garage collecting dust. So it's telescope collecting dust syndrome. That's what it is. So the book is I try to help people get some good experiences early on with their telescope and use it more, and you make a real hobby of it.
Yep. And that's a part that's kind of surprising, right? Is that there are a lot of objects that you can see with a small telescope. Some of them are actually quite exciting to look at and give you a real sense of what the object is.
Sure. I think, as a lot of amateur astronomers tend to go to things like, M13 or M31, the Andromeda Galaxy and these kind of, I guess, flashy things. But for a beginner, there's actually a lot of beautiful things like, colorful double stars, Alberio. So there's, double stars, triple stars, a wide spectrum of colors just for stars that is actually quite enjoyable for a new person to look at. Asterisms of all kinds. That's what I tried to focus on. Easy things to find that were very different. And there's 101 of them in the book.
So give us some examples. You mentioned some there, like Alberio is a classic.
Yeah.
Such a wonderful double star. What are some other kinds of objects that you recommend people who get a small telescope, say like the one that I've got there behind me? What kinds of targets do you recommend they go after?
Well, I try to find easy things. Like a good one I think for a beginner is the Ring Nebula in Lyra. Right, that's really kind of nice. It's for somebody who's never seen it before through a telescope. It's impressive. It's like a little powdered donut. Mm-hmm. People are always surprised by seeing something like that.
And it's pretty easy to find which is what I like, because it's sort of like right in between those two stars at the end of Lyra. It's easy to find Vega, and it's summertime in the northern hemisphere, and it's easy to find those two little stars at the end, and it's right in between them. So it's a sort of a nice one to find, and has I think that was probably my favorite object to look at with the visible eye anyway.
Yeah, and another good one, like a lot of beginners ask, what's the farthest thing I can see? And with the telescope, and there's a lot of debate about something like that, but I ended up choosing M109, which is a galaxy in Ursa Major. It's kind of pretty much at the far end reach of a small telescope. So people like that. I for the book, what I did was I kind of made a detour. We started out at the moon, and I said, well, actually you can look at the moon and see some things don't just look at the moon, but look at the moon in different phases, and you get a really different look at it and see how it changes. And then from there, I went out from the larger planets, the gas giants, and then out into our galaxy to see a lot of the things like that. And then after that, I progressed out to other galaxies and things that are extra galactic. So it's kind of like almost like a tour, so people could get a sense for how far away things were generally. So I covered a good cross section of things.
All right, so now it's time for that classic question. Then, if you've now got 101 things to buy with that small telescope, which telescope do you think people should be looking at to complement these? So after they've bought your book, then they need to go out and buy a small telescope. Now that they know that they're not going to collect dust, where are you leaning these days on telescopes to get?
I personally, for a small telescope, I like a refractor somewhere maybe in the 80 or 90 millimeter range. Something that's portable on an equatorial mount, something like that. That's pretty close. What's that? 70? Looks like it might be 60
it's
or
a 70. Yeah.
70? Yeah.
It's a 70 like view on an equatorial mount. So it's exactly what you're talking about.
You can probably take some nice photographs with that too, right?
In theory, we just need the rain to stop. That's the problem that we have here on the west coast of Canada. Is it just rains for 6 months straight. So my good friends at Oceanside Photo and Telescope sent me this telescope, and I barely had a chance to get it going. So it's rough.
But something like that is wonderful because for a couple of different reasons. I tend to like refractors more, but also something like that's portable. If somebody lives in the city, their experiences can be, dull. You can throw that in the car and head out somewhere where it's a little bit darker.
I will debate its portability, actually. I think it weighs about 80 pounds. Yeah, it's a monster.
Oh, it does. No kidding.
Yeah.
It's a very sturdy mount.
Very sturdy mount, right? Yeah, which is good for astrophotography and things like that. But no, it's a very overbuilt mount. So just to kind of set the stage for people, right? So like you've got those two main classifications. You got the reflector and you've got the refractor. The reflector is the one that has the mirror in it. The refractor is the one that has lenses, kind of like a traditional pirate telescope. And of those reflectors, you've got those Dobsonians, like the one you've got there, that you built. So if you've got a person who wants to get their first telescope, and you're going to have to ask them a couple of questions, which way are you going to try and point them, right?
I generally point people towards the refractors.
Yeah.
For me, they seem to be, they're more, I guess, eponymous of what a telescope is. When people think of a telescope, tend to be easier to use because you just look through it. But if a person has good technical ability, is kind of familiar with scientific stuff and electronics and things like that, they can go with a reflector because for the same price, you're actually going to get a lot more light gathering power with a telescope with a mirror in it.
Yeah.
You're going to get a bigger telescope that's going to enable you to see further out into, see things better for the same price. So that's the thing, but a bigger telescope like that, you have to consider too, that it's probably going to be bulkier, more work, come in two pieces that you have to put in the car and take somewhere or to set up outside or something like that. So there's a lot of things to consider, when it comes to buying a telescope. And
that, of course, was a trick question, right? The right answer is buy a pair of binoculars.
Right. That's right. You're right. That's a good way to start out.
Yeah.
Right. Yeah.
And that's always my recommendation. And so, what percentage of these would you say you can see with a pair of binoculars?
Oh, good question. I never really gave it any thought. Maybe, I guess that depends on the binoculars too, right?
Yeah.
The size of the binoculars, but probably 50 millimeter binoculars, right? You're probably going to get almost all of them.
Yeah. I use I don't know if we can see them in the screen. I've got a pair of 15 by 75s, sort of the Celestron astronomical binoculars, and they're not that expensive, right? They're like maybe $75. They come on sale on Amazon from time to time. They're not that expensive.
No kidding.
And they're big, right? And they're a really great way to just kind of lay back and observe the night sky. Like I taught my wife, it's funny, we went to a fairly dark sky location. I could teach my wife, and here's Hercules. Here's the star cluster in Hercules, and she can now find it every time. Right, we go outside and she goes like, oh, there it is, and with the binoculars, and it's amazing. What about sort of finding your constellations and stuff? What do you how do you feel about sort of getting people up to speed on finding their way across the night sky?
Yeah, that's a little bit tricky, and one of the reasons for TCD syndrome, right? But in the book, and I recommend people start at the North Star, start at the Big Dipper, find the North Star, and then from there branch out slowly to find the circumpolar constellations. And from there, it's kind of a little bit of a hop to track along the Milky Way or find anything. If you can find the 5 circumpolar constellations, you're going to be fine. From there, it's easy to spread out. But it's a good place to start.
Which are those constellations?
Oh, let me see. Ursa Major, Ursa Minor, Cepheus, Cassiopeia, and Draco.
Right.
Yeah.
And you can sort of find your way around.
Yeah,
around them.
And those aren't too bad, particularly the Big Dipper, which is Ursa Major, right? Particularly that one's really easy, and from there it's a good start. You can branch out, and then people get comfortable quickly, and before you know it, a person's actually taking the telescope out on a second night. That's a big deal.
A couple of people in the chat are mentioning that they have a hard problem with binoculars just because they're very often can be very heavy and they're hard to hold steady. There's a couple of solutions to that. One is you can throw money at the problem, which you can get these amazing the image stabilizing binoculars that come from Canon, and they're about $800, which is crazy, really expensive. But you press a button, and the what you're looking at just stabilizes. It's as if you're looking at a photograph with your eyeballs. It's amazing technology. I've had a chance to play with them. I don't own a pair because they're just incredible.
I've got a cheaper solution. Buy a pair of barbells.
just work out.
Right, that's all right.
Just get swole, and then you're
good. You'll hold those binoculars longer. Yeah, you'll be good now.
Yeah,
that's a good point. No, go ahead.
Well, so I mean, a lot of the good astronomical binoculars will have a tripod mount on them, so you can treat them like a telescope, bolted onto the top of your mount, and then you can be able to view the night sky.
Yeah. It's a really great way for people to start out. Really is. It's a funny thing that you mention it because I've been emailing back and forth with a gentleman named Norman Butler, and he's written a book on binoscopes. And he's coming out with a new book on binoscopes called The History of Binoscopes. So that's kind of an interesting thing, right?
I've seen someone had one. It's like a big chair, like a almost like a gaming chair that they sit in, or like a pilot chair, and then it's got this huge pair of binoculars that kind of puts the eyes right in front of their face, but then it's probably like 2 Dobsonians on either side of them, like some kind of anti-aircraft gun, and then they can move around in this chair and be able to see the night sky with binoculars. So that's just like gear dreams.
No, that's throwing money at it.
Yeah. Exactly. Yeah, throwing money at
that's burning money.
Yeah. Now, what about what's a good way for people to kind of get out and get a chance to try some telescopes if maybe they don't, if they want to just sort of know what it's like to see different types?
Sure. Of all the sciences, amateur astronomy is probably one of the most active. There's hundreds of amateur astronomy clubs dotted across the country. Contact a local one. Get in touch with them, go to a club meeting. I have 3 different astronomy clubs within easy driving range of where I live here in New England. So, they'll be a good source for you to go meet people, see their telescopes, use their telescopes. They always have open houses at night where you can go and everybody have their telescopes out and you can get a look and see what you like. That's a really good point. Because there's 1,000 different types of telescopes. It can be confusing. Yeah.
How's the light pollution in your part of the country?
Yeah, it's pretty bad. All the eastern seaboard is not good. I go to one club that's on the ocean, so that kind of helps half the sky with darkness. Right? Yeah.
There's almost nowhere. I mean, you look at say the Dark Sky Finder map, and there's nowhere from like the middle of the United States to the eastern seaboard There's these tiny little dark sky preserves, but for the rest of that, there's really no good dark sky places to go. It's awful.
Been viewing here in New England all my life, and just recently, last year, I went to the Grand Canyon, and in Arizona is famous for its night skies. So of course, I made a stop in at Lowell Observatory in Flagstaff, and spent an evening. And I was shocked by the difference. And the Milky Way pops out there. It's a big difference from, living in, Massachusetts. It's really beautiful. So, and that's an interesting point about the book too, is that I had to kind of generalize things, make decisions as to taking into consideration the whole country, what's going to be viewable at different times and different places, and what isn't viewable in New England that would be viewable in Arizona and stuff like that. Interesting process.
If you can only see, one star, then you're not going to be able to see all the objects in this book.
Oh.
So where do people get a hold of it? I'll hold up.
It's available on the publisher's website, ulyssespress.com, on Amazon, Barnes and Noble, and on my website, telescopenerd.com.
Right on. And where do people find out more about you? Is that at telescopenerd.com?
Yes, telescopenerd.com. Find out more about me. I have lots of articles and tutorials on, amateur astronomy, how to make, a how to make that telescope is on the website.
And just before we let you go, I mean, making a telescope is a great experience, and you can get a lot of help, right? You can get the mirrors already made for you, so you don't have to necessarily polish your own mirror. Like, it's not as complicated these days as it once was, right?
That's exactly right. And that's what I did with that one. I bought the mirror and the secondary and put everything else together myself, which is the mirrors themselves. That's a whole different ballgame.
Yeah. And so to have that step up, and then later on, if you want to polish the mirror, then
grind one out, and sure,
by all means. But
I tried doing a 4 1/4 years ago. I could never get it quite right.
Really?
Grinding it out and everything. Yeah, I could never get it configured right.
Oh,
so man. I said, you know what? I'll just buy them.
Yeah. I mean, like, so the mirrors, say, to do a Dobsonian, say like an 8-inch Dobsonian like that. What does the mirrors cost? Like, what are the parts to build your own telescope? How much?
Sure. Let me see. Well, it depends. I guess the cabinet going to cost you nothing if you can scrap up some decent lumber.
Yeah. Assuming the wood is kicking around.
Sure. The sonotube. I use sonotube. That's a construction tube that you pour cement, but I fiberglassed it. So there's a little bit of expense there, maybe $20, $25 to fiberglass that. An important part is the eyepiece holder. So that's something that I think that cost about $20. The mirror pair itself will vary depending on the company, but for an 8-inch, you probably can get one between $100 and $150 for the pair.
Yeah.
Secondary and the primary, somewhere around.
And so, really inexpensive way to get your hands on a telescope.
I recommend people, I recommend for people sometimes to try to see if they can find a broken down used one. And if the mirror pair is still good, just rebuild a new telescope around it.
That's a great idea.
Yeah, sometimes cheap.
All right, Will, thank you so much. Congratulations on the book, and keep your eyes on the sky.
That's right. Thanks for having me. It's great talking to you.
Take care.
Bye.
All right. Now it is time for the actual show part.
Morgan doing his stretches.
Yeah, I gotta get my calisthenics in here. I saw you lifting some weights over there.
Oh yeah, no, I'm getting.
He's getting ready for the binoculars.
Is that the word that all the kids are using today?
All right, here we go. Hello and welcome to the Weekly Space Hangout for Wednesday, February 28th, 2018. I'm Fraser Kane, publisher of University. I'm Fraser Kane, publisher of Universe Today. You think I would know the name of my own company? Joining me, actually, first, we're going to be talking about the James Webb Space Telescope in trouble again. Maybe talking about a super flare striking Proxima b, space bugs on Enceladus, LT on the moon, what's going on with Lawrence Krauss, the Strato launch, early hydrogen scene. We got a lot of stories we're going to get through, and we're going to go fast. Joining me quickly at top speed this week, we've got Dr. Morgan Renberg. He is the Director of Scientific Presentation at the Fort Worth Museum of Science and History. Morgan.
Hey, Fraser.
Camera went to Paul.
That's right. Can't resist me.
You know what? You are not to be seen, Morgan. It's just Paul all the time. All right.
Fair enough.
Also joining us this week is Dr. Paul Sutter, astrophysicist at Ohio State and host of Ask a Spaceman. Paul, still on the camera. Welcome.
Still on the camera. Can't get off me.
Kimberly can't join us for unknown reasons. Something, busy, family, something. Anyway, but we're going to move on anyway. It's too bad because we're going to miss her. She was going to talk about extrasolar planets, and we're going to have to. Yeah, it's not like she's gone forever. But we're going to have to fill in on this whole Proxima B story, and it could just go sideways. So who knows what's going to happen? All right. Well, Morgan, since the camera just can't take away from Paul, I want you to go first, Morgan. Tell us about James Webb. Now I'm just bracing for impact. What's the news?
Yeah, I got some bad news. JWST is probably going to get delayed again.
What?
And in fact, there's a number of reasons for this delay, and news that this might happen came to us today from a U.S. Government Accountability Office report that reviewed Northrop Grumman's progress constructing the James Webb Space Telescope, and basically found that they were getting farther and farther behind. And now that they're still more than a year from launching in mid-2019, but they only have about a month and a half of slack left in the schedule. And because of this, they're now working 24 hours a day on the spacecraft. They have engineers in 3 shifts working 24 hours a day, which basically means that there's no room left to make up schedule. Because the way you normally catch up is by working more, but they have a full team working 24 hours a day to build the spacecraft now. And so even if everything went perfectly, they would just slide in under NASA's deadline. But everything isn't going perfectly. And the report cataloged a number of issues facing James Webb. One is that half of the thrusters last year were found to be leaking. And Northrop couldn't figure out why. They never could understand why they were leaking, so they had to rebuild them one by one. But more distressingly than that, they found that during a test earlier this year when they were trying to unfold the spacecraft, you might remember that James Webb goes onto the Ariane 5 rocket kind of folded up like a flower. And then in space, it will unfold to reach its full size. But when they tried to unfold it, one of the 6 supports that were supposed to help support the sunshade got stuck. And
so finally a practical use for origami.
Yeah, that's right. I have to admit, this is
origami. It doesn't work.
Yeah, this is the first time that I think I'm actually legitimately worried about what's going to happen with James Webb, because ever since anyone's ever seen an animation of how this thing was supposed to deploy, the question was, what happens if it gets stuck? And the basic line has always been, it can't get stuck. It's unstuckable.
Failure is not an option.
We need it to not get stuck. That's the way this is going to play out.
And now we hear it got stuck. A year away from when it's supposed to go into space. The very most basic functionality of the telescope, just forming itself into a telescope, it didn't work. And for those of you with memories of the Hubble debacle when it launched, this has to be a flashback of that. And the trouble is that fixing these sorts of things are going to take more time and they're going to take more money. But there's already a cap on the amount of money that the U.S. government can spend on the James Webb Space Telescope, $8.8 billion. And no one really knows what will happen if they go over that cap. Because, in principle, going over that cap is supposed to trigger ending the mission.
So,
but in practicality, will that happen?
Well, there is like no way they will cancel this telescope. They are deep into the sunk cost fallacy
they canceled
now.
W first.
Well, see, so this is the thing, Morgan. You just like last week said, don't worry, everything's going to be fine, when they canceled W first. They haven't canceled James Webb, and you're worried about it? Like, you were worried about a canceled
James Webb is an
spacecraft?
actual existing physical thing. W first is a dream in some engineer's mind.
Well, made from a
James Webb, we've
spy
spent
telescope.
billions and billions of dollars on, and it doesn't work.
W first is a real instrument.
Yeah, it's a real telescope. It's got spy, it's still got all kinds of secret spy stuff all over it, but it's,
Yeah, they're too busy. They're scrubbing off all
the secret spy information.
But
Yeah.
it exists, and they canceled it.
Yeah.
I don't think W first will get canceled, but this is so frustrating. Like,
Okay.
yes, I guess we want to take our time.
All right, you know what? Place your bets right now. W first gets canceled. I vote that it will. Not that I wanted to, just super clear. I do not want W first to be canceled, but I got this bad feeling that it's going to go.
I think W first will make it.
Yeah.
But this raises serious questions of how the heck are we going to do astronomy, space-based astronomy, over the next 30 years?
Yeah, well, okay, so let's go back to that sunk cost fallacy, right? I mean, there's no way they're going to stop working on James Webb. They've spent billions, so they need to bring in a couple of origami experts to help give it a few tweaks, right? This thing is going to fly. It's got to fly. You already said it will fly because we want it to fly.
Yeah, it's going to fly. There's little question about that. But is it going to work? For the first time, I sort of am fundamentally worried that it might get out there and not work. Because here we are 95% of the way through the process, and it doesn't work. And if that's not an alarm bell saying, holy cow, this thing is not guaranteed success, I don't know what is.
It has a docking ring. Orion could go there with, like I said, a crack team of the finest origami experts on planet Earth. It'd be like Armageddon, but there's something in there. Anyway, Origamageddon. Anyway, as a docking ring, they fly out, they fix it, and then it's better.
And then they die in space because you can't come back.
Right. Yeah.
The sun shield is actually like the most important part to work, because if that part doesn't work, by the time you get out there and fix it, there's going to be a lot of heat in those very sensitive instruments that you may or may not be able to recover from. It's one thing if the telescope mirror doesn't fully open, because as long as it's just sitting there, nothing's happening. But if the heat shield doesn't work, the heat shade doesn't work, that's a serious issue for preservation of the instruments and of the science.
What about they take James Webb and they put it in a BFR and a bunch of astronauts, and then they fly the whole thing out there, and then they just stay around and they make sure, or no, what if and then they just make sure this totally set up, and then they fly home with the BFR.
So, Paul, I want to ask...
Hey, we're just going to ignore that suggestion for you.
Yeah, I'm just going to ignore that. And I want to ask you about sort of your rhetorical question from before. Whether or not, how are we going to do space-based astronomy in the next 30 years? Yeah. Is there any merit to the idea that rather than trying to go deeper, we should, just build 25 Hubbles and launch them all? Because Hubble is so oversubscribed that the amount of science that Hubble could do but can't do because there's not enough time on it is so vast that we build a design that we know basically fundamentally works, and we just launch a crap ton of them. And that's astronomy for the next 30 years until we have the BFRs working at such a scale that sending up a full-size James Webb is nothing.
Is trivial. Yeah. And I think I don't know what the right answer is, but I think that's a very smart idea that's worthy of discussion. We have this view in astronomy that the only way to sell a project is to go deeper, to go bigger, to do Hubble plus plus, and then we're going to do JWST plus plus, and we're going to solve the biggest mysteries in the universe, when really it's going to be incremental science, it's going to be incremental improvements, where you can get those incremental improvements in other ways, by using better ground-based observatories, by doing, like you said, 25 Hubbles instead of one. And tons of science will still get done. Tenure track appointments will still get made. Papers will still be published. Conferences will still be had. The progress of astronomy won't halt. It'll just shift direction and shift focus. That's not necessarily a bad thing. We shouldn't be afraid of that as a scientific community. We should be open to having exactly those kinds of discussions.
How oversubscribed is Hubble?
It's like 10 times, isn't it? The acceptance rate in the past has been 10% or less, I think.
So
there you go, 10.
How ready? So I guess here's the other question then: are we now just going to enter the era of ground-based astronomy? I mean, the ground-based telescopes, there's a lot of projects in the works. They all seem to be moving forward. They won't necessarily have that deep sensitivity, but they are going to bring a lot more observatories online of sort of a previously unseen scale. Is it going to be ground-based telescopes for the next couple of decades that fill that gap until this next promise of space flight moves forward?
I think you could ask the same question, though. What if you built 20 Kecs instead of 5 30-meter telescopes? Would you get overall better science, even though you're not probing the outer limits of what we know?
Yeah, I think another way to phrase that is we have not exhausted the supply of science available with current levels of technology.
Right. So you would be for then maybe that's a more practical question, right? Would you be more for 10 more Kecs at 10-meter telescopes, dotting around in Chile, than one 30-meter telescope?
Maybe. Let's have the
you want a 30-meter telescope? Come on.
I mean, none of my personal interests or research interests align with a 30-meter telescope. So it's not like I have some big dog in the fight. Yeah. I like giant telescopes because they're fun, but I also like lots of telescopes, which is fun in a different way.
Yeah. I think Morgan's proposal is exactly right, which is that if the scientists are waiting to get their research done, and you've mentioned, Paul, how hard it is to get a job as a professional scientist, and if you know that there's not a lot of positions, you go through this whole rigorous process, you've dedicated 10 years of your life, you get a position, and you still can't even get telescope time. That's just the worst.
That's the worst. I mean, This is, I think, the story of JWST, the story of what's happening with W First, is a symptom of what's happening to the larger astronomical community and scientific community in 2+ decades of flat and declining budgets. Of how do we keep doing science?
That was I don't know.
I don't know either.
All right, let's move on then to something that we do know.
That was a bummer.
Yeah, well, that's like half. Yeah, but what could we do? We're going to talk about James Webb, and there might be some problems. And so, how could we go?
We talk about something happy like Lawrence Krauss.
we'll get to that.
Okay.
Oh, let's talk about space bugs on Enceladus.
Yeah. So I brought up this story despite knowing almost nothing about this field, but apparently Enceladus, has these geyser plumes that you can get Cassini looked at and figure out there are some elements floating around in there, like hydrogen, like carbon dioxide, like ammonia and sulfur, which indicates that there is hydrothermal activity at the base of the subsurface oceans of Enceladus. So the question is, could little tiny space bugs be eating the hydrogen and spitting out carbon dioxide or methane, spitting out methane at these hydrothermal vents in Enceladus. And that leads to the question, are there any possible analogs on Earth that we could study to gain some insights into the potential habitability of Enceladus? And the answer is kind of, sort of, maybe. There is a particular archaea creature, an extremophile, that when subject to the conditions we think happen under the surface of Enceladus, kind of live. They at least don't die.
So the conditions,
which is interesting,
the theoretical conditions of Enceladus found here on Earth, they found a nice healthy ecosystem. Therefore,
they took these creatures and then they stuck them in a lab, and then in the lab they recreated the Enceladalian conditions.
Enceladasian?
I like Enceladasian.
Yeah.
Enceladon,
I don't know,
is a dinosaur.
Right.
The conditions of Enceladus subjected them to that, and the archaea were just like, yeah, whatever.
Right. And so that means that later on, when we send the spacecraft back to Enceladus filled with this payload of archaea and to deliver, they should be able to survive perfectly well down there. Planetary protection be damned.
Perhaps, yeah.
Yeah. No, actually,
so we can start colonizing.
And this does relate to another story, which is that someone did the math, and apparently there's going to be tons of bacteria on the Musk mobile in space, and it could very well create a planetary contamination over the next few million years, depending on where it goes. And so I believe you coined the term Muskspermia.
Muskspermia, it's a thing. Yeah.
Or a backup of life on Earth when the robot uprising happens, which Musk was supposed to prevent, and then
which I think he's going to cause. Actually.
Which he's going to cause, but then we've got a backup of tiny Earth-based bacteria floating in a sweet Tesla, orbiting in the solar system.
This Enceladus story is not at all surprising to me. I've been saying on this show for years that I think there's probably myriad locations in the solar system where Earth life can survive, where life in general can survive. The real $64,000 question is, in a place like Enceladus, can life begin?
That is a much more difficult question.
Yeah, all sorts of habitats on Earth we find life, but I think it's not very plausible to think life arose in those conditions. It arose in sort of nice, comfortable conditions, and then over the course of millions or billions of years, it spread and evolved to survive and even flourish in these really harsh environments. But if you're stuck in a super salty, super cold, mineral poor environment, can the chemistry that needs to take place to sort of kickstart life ever happen? And I think that question is the difference between whether the solar system is full of life and it's not.
But I guess the thing that we don't understand is just what was that first, obviously what was that first event? Where did that first life come from here on Earth? And those regions of Earth at the bottom of the oceans where you've got this volcanic vents venting into the ocean and producing all of these chemicals are theorized to be one of the places where life could have gotten that first toehold. So then to think, wow, there's all of these other worlds across the solar system that have these same conditions, it doesn't feel like an enormous stretch. And then when you also walk around and pick up chunks of asteroid from Mars and Vesta and things like that here on the surface of Earth, and you can think that maybe life is getting around via Tesla roadsters.
It's not at all out of the question.
Yeah.
Not at all.
And so, who knows how many times material from Earth has made it to Enceladus or Europa and vice versa. More likely vice versa, because they've got less of a gravity well to get out of. So we need to go back. There's nothing.
Need to go back. If only we had like a large space-based mission to help us get there. Well, but no, we're spending more money fixing the origami on JWST instead of launching cool new stuff.
Man, all right, let's move on.
It's kind of been a bummer all.
It really
all
is, but we're gonna take it. Okay, so I'm gonna talk about the Strata launcher, and then we're gonna the Strata launch, and then we'll go from we'll have a couple of other conversations we want to talk about here. Okay, so people always ask me, why doesn't anyone take a rocket, bolt it onto the bottom of an airplane, and then fly that airplane up to a high altitude and then launch the rocket from the bottom of the airplane, and you get all the advantages of getting high up above the atmosphere, and you've got a certain amount of velocity. Wouldn't that be awesome? Now, it's already done. There's the Pegasus rockets, which have been flying for quite a while, and they do exactly that. They launch from the bottom of some Boeing airplane, and they fly off into space, but fairly small. And there's the Minotaurs as well, but the kind of ridiculous version of this is called the Strata launch, and this is a Paul Allen funded venture, and it makes a ridiculous airplane. I believe it's the biggest airplane ever made.
It is. I think it's bigger than the Spruce Goose.
Yeah. Which, there you go. And so in theory, this thing is going to be taking off in 2019. It's a 500,000-pound airplane, wingspan of 385 feet. Apologize for the imperialness of this. But it will be able to carry rocket payloads of about 550,000 pounds underneath. And it has sort of looks like two airplanes joined at the wing with 6 huge jet engines. And so they did this test the last couple of days. They drove around on their runway at 46 miles per hour, and that's all they did. But in theory, over the next little while, they're going to keep doing some tests. But that beat the last test, which was 28 miles per hour back in December. So it's a huge. They went double the speed.
You have to see the video.
Yeah, so I'm going to put the video up so people can see it.
Notice especially the chase cars following it that look like RC cars or something in comparison
the
to
trucks. Here I'll put the sound on too here. I'm sure I'll get a copyright strike. So I apologize to the podcast listeners. Imagine a gigantic. It's hard to explain.
You just have to look the video.
Yeah, you have to look. Search for Strata launch video. There you go.
It's supposed to fly next year.
Yeah,
and so I'm not sure we can count it as an airplane until it flies, but it's supposed to fly next year, and they ought to just sell them to billionaires, and they could build their houses inside of it or something.
Yeah, like floating porches. Here is Fraser's atmosphere Venus colonies. Right? You just put a giant dome on top of one of these and stick it in the Venusian atmosphere and have at it.
Yeah. This thing is ridiculous. And so the question is, of course, will it end up like the Spruce Goose? I mean, when you look at what's happening, so what do you guys think? Morgan, what do you think about the fact that now SpaceX is landing rockets? We saw the twin booster landings. Is there a place for these kinds of complicated launch systems that are still going to be throwing away parts of the rocket?
It's hard to see a place for them long term, I think. They might have a window right now where even, so-called reusable rockets like the Falcon 9 or the Falcon Heavy really are throwing away a big chunk of their rocket. But as soon as someone, whether it's SpaceX or Blue Origin or another company, takes the leap to fully reusable rockets, it's just very difficult to see a system this complicated being any more cost efficient. If all you're paying is the fuel cost for the rocket and the fuel cost for the plane, they're not going to be so dramatically different as to make the plane an obviously better choice. And a big rocket's always going to be able to put more into space. So 500,000 pounds is a lot of stuff, but it's not a Falcon Heavy worth of stuff. And that is a problem once the Falcon Heavy or its successor becomes so cheap that it doesn't really matter how much it costs.
Now, you can imagine one improvement where they maybe do get that first stage to make it reusable. Like maybe they use it to launch some version, like a Falcon, a smaller Falcon, or maybe some custom built rocket that is able to land downrange, but still you're still going to lose that upper stage. Like it just feels like if SpaceX gets the BFR going, top and bottom, fully reusable, it's game over for every other launch.
But that's a bunch of big ifs, right?
Is this thing supposed to be piloted? Like, are there humans on board flying this?
Yeah.
Yeah, that's like a big safety issue in comparison to a normal robotic launch. It basically turns every launch into a crewed launch with all of the risks and safety costs that are attendant to that. Sure, the plane isn't a rocket, but it's carrying a freaking huge bomb underneath it, and it's going to drop that, and that thing's going to light. And anywhere along the way, if something goes wrong, you have crew in danger. And to me, that seems like a major liability in comparison to a fully autonomous system, like basically any other company is developing.
Yeah, it's gonna. But I love just the audacity of it. Like I just love the size and scale of this thing. So I'm pretty stoked for it.
Are there any other uses for a big giant airplane?
What about?
I bet the military would have some.
Yeah, or like sounding rockets. Like what if they like carried a bunch of sounding rockets up as well, and maybe could really bring the price down for those? Because, I mean, the issues that you just mentioned, those also do come up with things like the Pegasus and the Minotaur and stuff. So you are launching a rocket from a piloted aircraft. So that's already been worked out.
Yeah, but those things launch pretty infrequently. The future of rocketry, as Blue Origin and SpaceX are painting it, are, launches every day.
Yeah.
And at that cadence, a human crewed plane is going to have a lot more trouble. It's one thing if you're only launching it a few times a year and you can refurbish the whole thing, but SpaceX, frankly, may not care if every 100th rocket blows up. As long as they're ensuring their payloads, that's still going to be very cost effective. But if every 100th piloted launch blows up, that's a catastrophic result for the company.
Now there is a man, I forget the name of the company. We're actually reporting on it right now. Maybe it's already come out. The spin, man. So people want to do a catapult, and so that's another. What's that?
Or is it a trebuchet?
Trebuchet, yeah, space catapult. So I think that's going to be the next step. Is the way you beat something like the BFR is with some kind of propellantless launch system.
The thing is, the laws of physics do not permit ballistic flight to put objects into orbit.
A little bit of propellant. It's hit
literally
apogee,
impossible.
You hit apogee, and then you fire your little bit of propellant, and you put yourself you circularize your orbit.
I just finished a script about 50 years of space guns, and they're really complicated, and they don't really work that well. And a space trebuchet sounds sweet, but probably not going to be launching stuff that's big enough that anyone cares about it.
Right. And only if you get to escape velocity, your spacecraft is coming back to Earth no matter what. So, okay, well, let's move on to one last uncomfortable story, but we should definitely talk about it. And you brought this one up, Paul, and he's in your field. So why don't you go ahead and set this up?
Yeah, so Lawrence Krauss.
Dr. Lawrence Krauss.
Professor Lawrence Krauss. The rank of professor is higher than the rank of doctor, if I remember right. Is a cosmologist, formerly at Case Western Reserve University in Cleveland, and then for the past, I think, 15 years at Arizona State. Science popularizer, author, bunch of books, been in a bunch of TV shows, big figure in the skeptic and atheist community. And serial sexual harasser of undergraduate women and other unassociated young women.
Alleged by a news story that came up from BuzzFeed.
So BuzzFeed broke the story a few days ago, based on quotes from the accusers, and then also from emails exchanged both between Krauss and BuzzFeed, between Krauss and Case Western, between Krauss and, I believe, Arizona State, and then also internal emails between the accusers and various review boards at Perimeter Institute and Case Western, who years ago had denied any further involvement with Krauss, refusing to let him come back for speaking engagements because of these allegations. So I feel like the Me Too movement is coming full circle. If you remember a couple of years ago, it a couple of years ago?
Yeah.
There was the astronomer Berkeley, Marcy, who was abusing his position and abusing young women in his orbit, and so the academic world kind of went through these throes of finding these horrible people, these monsters in the community, shining some light on them and getting them kicked out. And then the attention turned to Hollywood recently, and now it's interesting because Lawrence Krauss sits at the intersection of the academic world and the Hollywood popular world. And I feel horrible for these young women who had to have these miserable encounters with someone like that, and who had their lives forever altered, forever shaped by these negative interactions. But also because Lawrence Krauss was a science popularizer, he was representing scientists to the broader world, and it's like really like someone who is such a public figure, a public face for something as positive as science in the search for meaning and understanding in our universe, turns out to be a really horrible person, and we can't rely on that person anymore.
Yeah.
It's infuriating that these sorts of individuals are enabled and permitted to continue for so long. It's incredibly disheartening, as you said, Paul, that someone like him was, or continues to be, is one of the faces of science to the world, because this behavior like this has no place in science. It has no place in society. And I think just as we felt a couple of years ago with Jeff Marcy, this is not the last word that's going to be spoken on this issue. And I suspect that as the Me Too movement continues, we're going to find more and more of these powerful and popular and well-recognized individuals who took advantage of and abused their privilege and their position and the adulation that so many of us have given them at one point or another. And it's just so frustrating and saddening that we have to sit and have this discussion again and again.
So a couple of people are just mentioning in the chat, sort of, they're wondering about the accusations and stuff. I highly recommend you read the BuzzFeed article, because it is a incredibly well-researched, well-reported piece of journalism. That it is, they took a long time to put this story together. Every fact, everything that they mention, they then back up with various lines of evidence. Just to read that BuzzFeed article is to see sort of one of the best pieces of journalism that sort of had to come out of this. And I think part of it is just it shows you the level of detail and work that people have to go into to even get these claims out there into the open. And it's sort of,
people have known about this stuff for 15 years, for 20 years. This is not a secret in the community, but to get people out on record, BuzzFeed is really at the forefront of doing this. They're the ones that broke the Jeff Marcy story a couple of years ago. They deserve our credit and our respect for the immense amount of work that goes into making these things happen, because the amount of potential you have to overcome to to take that step and get those accusations out there in public is so enormous.
Yeah.
That
and the women who came forward, because there's
absolutely
gain from coming forward and everything to risk, which is part of the system that allows these kinds of people to keep perpetuating what they do, because the system disincentivizes people who have something to tell.
And I think we're just really learning, right? Like, these situations have been happening for years. These imbalances of power, these abuses of power, etc. This has been going on for a long, long time. But now the internet, the way that people can connect with each other, the way that they can sort of out these people, I think, that from, as you mentioned, it has come full circle from when the ball really started to get rolling back a couple of years ago with Marcy and others, and moved through into Hollywood. It has, yet to make its way through corporate America, other countries, what goes on in Europe and places like that. Like, there is... that I don't think this movement is going to go away, and I think it's just going to build. And I think, it's great to have. I mean, it sucks to hear the depth of what people had to go through, but it is so great that people are feeling like they can come and they can stand up and they can say what's going on, and there are serious consequences for people who think they can get away with these kind of activities.
And there are consequences for the rest of the community, because now it also really sucks. In addition to the damage he's done to the women, he's also damaged science as a profession, the academic world, science communication
movement, all of that.
The skeptic movement. Like, now, not only do we have to defend our point of views and how we look at the world, we also have to defend that, no, we're not all creeps. We're not all serial harassers, that there is legitimacy, there's good humanity to be found in the academic world and in the science communication world.
And it scares away the great scientists that we need contributing to these work. Imagine how many more stories we could be talking about every week if everyone who felt an interest and a desire in pursuing science was actually able to, felt safe in doing so, felt empowered to do so. We're missing out on so much discovery and so much opportunity because those who misuse their power push away the enormous number of people who walk away from science every year and say, I'm never going back to do that again.
Yeah, I'm sad that Kimberly wasn't here. It would have been great to have some more guests. I mean, I think just a couple of weeks ago, you had Pamela and Nicole and Kimberly, and you had would have been a good counsel to talk about this. And I'm sure Pamela and I are going to be talking about this a bit in Astronomy Cast this week, now that everything is quite public.
And hats off to Aunt Pamela, because she's been talking about this kind of stuff for years.
Yeah. I mean, anyway. Yeah, you're exactly right? That she knows and has been called to testify for all kinds of situations. I don't know about this one specifically, but has definitely been sort of involved in a lot of in providing evidence. And it's a really hard thing to just, she wants to just use science, right? She just wants to look at stars and share it and talk about it like the way we do and get to, and don't have any concern whatsoever. So I think this is not the end. This is not the beginning. This is the end of the beginning. There's going to be so much more. The middle of the beginning.
Of the beginning of the intermission.
Yeah, right.
Of the end.
Yeah. So buckle up. There's more coming.
Yeah. Shine the light and watch the rats.
Yeah. So before we wrap up, there's one interesting story, and I know you were looking at it, Paul, and I can see Astro B would love us to talk about it, and I had brought this up earlier with just this new observation about early hydrogen, 180 million years after the Big Bang. What are we talking about?
Yeah, super briefly, we've been hunting for the signals from the very early universe for a very long time. It's an incredibly difficult measurement. This is when the universe was still dark, when the universe was first lighting up with stars. It was filled, brimming with neutral hydrogen gas, which doesn't glow very brightly. But so as stars began to form, they heated up this gas, they excited the gas, and this enabled the gas to absorb some of the cosmic microwave background that was still permeating the universe. And this subtly, at a very, very tiny effect, changes the signal that we see from this neutral hydrogen. And for the first time, this signal has been detected. And the signal is actually a little bit stronger than we expected. And we're not exactly sure why. It looks like the gas is a little bit colder, or about 2 times colder than we had expected, than we had predicted. We're not exactly sure why that gas is colder. The hypothesis that the observers advanced, that they wrote up in this paper, is that maybe there are some interactions between dark matter and normal matter that are giving normal matter an avenue to release some energy. It's sinking it into the dark matter where it ends up being hidden. We can't see it. It's cooling off the gas faster than you would normally expect, which would give rise to this signal. Not 100% solid on that line, because we have this one piece of evidence as the 3.8 sigma detection. So it's a relatively solid detection. We need a lot more. This is a great example of how this untapped well of cosmology is sitting right there if we can make these very difficult measurements happen.
And actually, Katie Mack, who has been a guest on the show in the past, she did a great article for Scientific American, and I highly recommend you dig it up, because it's got some other interesting implications for dark matter, and you know, it sounds like a really fascinating discovery. It's kind of hard to wrap your mind around, because it's not black holes and, you know, all kinds of cool stuff. It's hydrogen was a little colder at the beginning of the universe than
but this is, we're going to see more of these kinds of stories as all the radio instruments that are targeting this epoch get better and better and better, and actually start to uncover the signals over the next few years. We're going to see more results from this era, from this epoch, from the cosmic dawn, from the dark ages. And there's going to be some surprises for sure. There's a lot of cosmological information buried in there.
I mean, does this feel like one of the bigger stories of the year?
No.
Okay, then never mind.
Because it's one interesting detection, which itself is worth celebrating and talking about. The hypothesis that the observers advanced is a possible way to explain the observations.
Right. All right, now it's time for our interview. Interview's over. Right on. Well, hey, we're running out of time. We got a book, so we better move quickly. Before I say goodbye to my co-hosts, I want to say a big thank you, as always, to the Weekly Space Hangout crew. These are, of course, the wonderful community that work with us to make these shows, to organize our guests, to handle the chat that's going on down below. So if you want to be a part of this community, go to wshcrew.space and join. It's totally free, and there's many people who love this stuff as much as you do and would love to talk with you about it. So wshcrew.space. And the other thing is that if you are listening to this show and you are listening to it as a podcast, take a second and write us a review. Use whatever podcasting directory of your choice, be it iTunes or the Google Podcast directory, and give us a review. I'm not going to say do 5 stars, but, 5 stars. And that really helps people find our show. So if you want more people to be able to find out what we're doing, leave us a review. It means the world to us, the universe to us. All right, Paul, before I say goodbye, you got something interesting that you did? Anything exciting happening?
Well, I was going to say I was on a recent episode of How the Universe Works, but that episode was pulled because it featured another scientist that we may have just talked about. So I think the producers got to re-edit that episode before they actually
You might get another
aired.
call to say a few more things. All right.
Yeah, man. Yeah, so nothing big there.
You were almost a star.
I was almost a star. I've been in other episodes of How the Universe, so it's all right. But this was going to be a really fun episode because we taped some stuff in Grand Central Station, a movie theater, talking about time and space. Pretty awesome. Hopefully that episode sees the light of day.
Morgan?
Yeah, if you're in the Dallas-Fort Worth area, you should come by World of Beer in Fort Worth next Tuesday, this coming Tuesday at 7 p.m. because I'll be talking about the search for life in the universe as part of the Public Knowledge series. So come check that out. We're going to do some fun thinking about the Fermi paradox and where life could be. And hopefully we're going to drink a lot of beer.
Yeah.
So swing by, join in on that. And if you watch the show, please come introduce yourself, say hi. It's always fun to meet people.
Right on. And I mentioned this before the show, but I just posted a new video where I advocated for the Caesar mission to send a comet sample return mission. My buddy Tim Dodd, the everyday astronaut, he supported the Titan Dragonfly. We let everybody vote. I got destroyed, but we had a lot of fun. So go and check out my channel, watch both videos, and then vote. And because we're going to pass along this information to NASA, and they will then use that to, I'm sure, make a decision on which mission to send. So check that out. All right, time to go to the gallery view. Oh, there's only 3 of us. It's very sad. All right, thanks for joining us this week. Thanks, everybody. We'll see you all next week.